Just a little background in early brain development first. From birth, the brain develops from the bottom to the top and from the back to the front. The most sophisticated part of the brain, then, is in the front, top part of the brain, and it's called the prefrontal cortex. We'll talk about that more soon. The structure of the brain is fully developed at birth, meaning that the brain is fully formed, but the wiring of the brain happens through a child's interactions with others in the environment. And when I say wiring, it's just like the wiring on your house. You've got to get the wires from point A to point B and connect them to get a light to turn on. In a house, we physically take the wires there, and in kids, we create the wiring based on the types of interactions we have with them. In the past 15 years, the brain science has become clear. The more high-quality, responsive, and nurturing interactions, the more effective the brain. Now we'll get into brain development for kids ages 6 to 11. We see a major shift in working memory from about ages 5 to 7 and 10 to 12 in kids in the U.S. and other Western countries. And a lot of that is because of school responsibilities and just what kids are exposed to, what they do. The type of environment that a child lives in has a lot to do with that big shift, as it impacts the types of experiences that a child has. Just like in earlier years, the combination of the environment and the child's experience impact the child's brain development. When kids live in safe, nurturing environments with parents who are predictable, emotionally available, and who regulate their own emotions well, kids' brains develop optimally. What we do and how we are with our kids matters. More of what's happening. The prefrontal cortex, that front part of the brain, doesn't finish being developed until kids are in their mid-20s, but we see stronger connections being developed, sort of like a well-worn hiking path between 6 to 11 years of age. And the fatty layer around the nerve cells increases during these school-age years. That supports kids' executive function skills like paying attention, focusing on important information, planning, decision-making, being able to control their impulses even. Those fatty layers are called a myelin sheath, and they help messages get sent faster in the brain, which makes the brain more efficient. So we see kids getting better at these skills. Kids' brains also increase the myelin sheath, that fatty layer, and the corpus callosum, which is the band of fibers that connect the left and right sides of the brain, or the left and right hemispheres of the brain. And the corpus callosum is responsible for helping the left and right hemispheres to talk to each other, to work together more efficiently, especially in kids' cognitive, motor, and sensory areas of the brain. So we see language, coordination, movement, and learning academic skills are influenced, as the brain is quite interconnected before a child is 8 years old. We also see kids begin to lose nerve cells during the years from 6 to 11, and that's when they're not being used. That's fine for kids with positive environments because they lose nerve cells that they don't need. For kids living in stressful and conflict-ridden environments, that could be bad because the areas that protect the child's brain are being developed and strengthened, and that's to keep the child safe. And those areas responsible for learning and memory aren't being stimulated as much because the brain's just trying to survive without too much damage, and it doesn't have the energy for growth in other areas. An example is the prefrontal cortex, which might be damaged from a chronic, highly stressful environment, resulting in emotional outbursts, poor judgment, and an inability to plan in kids living in stressful environments over time. Another thing happening is the systems for visual spatial working memory, so that's seeing and understanding where you are in space. And also auditory working memory, so remembering what we hear. And response inhibition, being able to stop ourselves from doing something we shouldn't do. Those systems begin to split into different specialized parts, and that helps the child's brain process that visual, spatial, auditory information faster. And we see this in kids' ability to match pictures, remember spatial information, to not do something they shouldn't do, and their school performance. All of this helps kids be able to have better self-regulation, to control themselves a little bit better.